right, so this is our review, our Sunday review. So here we go. We're going to do the problems that I promised I would work from the homework. And this one is from section, these two are going to be from 5-1. And I got a request for 35 and 37. All right, so let's start with number 35. And the question is, identify the critical points and determine the local extreme values. Identify which critical points are not stationary points. Now, not stationary means they're moving, right? It's not stationary means
they are moving.
Well, f prime is undefined, right? So you have stationary points where the derivative is equal to 0, and not stationary points is where the derivative is equal to undefined. Undefined, right? Okay. All right. So the function is y equals x to the 2/3 times x plus 2. And I don't want to take the derivative of that using the product rule. So let's distribute. So we get y equals, this is x to the 3/3 here, times x to the 2/3, which is x to the 5/3, good, plus 2x to the 2/3. And now I'll take the derivative of that. That's nice. So that's going to be 5/3 x to the 2/3, good, plus 4/3 x to the negative 1/3. All right, so I'm going to put things where they belong. So y prime is equal to, this is going to be 5x to the 2/3. Oops, I'm going to get a common denominator in just a second. Over 3, right, plus 4/3x to the 1/3, right? So what's the common denominator here?
3x to the 1/3.
That's right. So this one I have to multiply by the first x to the 1/3, right? Over x to the 1/3. And what happens when we do that? We get 5x to the 3/3, which is 4x. So this is just 5x plus, and this one already has both pieces of the denominator, 5x plus 4. And then this is over 3x to the 1/3. Okay, so that's my derivative with a common denominator. And to find critical points, that's where y prime is equal to 0 or y prime is undefined. All right, so y prime equals 0 when the numerator is equal to 0. So that's going to be 5x plus 4 equals 0. And that'll be 5x equals negative 4. X equals negative 4/5. And y prime is going to be undefined when the denominator is equal to 0. And that's 3x to the 1/3 equals 0. And that's just x equals 0, right? All right, so let's do a sign chart. And I'm going to put my critical points on there. And so I get negative 4/5 is on here. And that's a 0. And at 0 we are undefined, okay? Now, I would like to superimpose the numerator and the denominator. What is the numerator? It is a
Positive line.
positive sloped line. Good. So I'm going to say that it looks like this. Passing through it, 0, right? And then what about the cube root function? Everybody remember what the cube root function looks like? Looks like the square root on one side, but it's odd, so it's going to go underneath, right? So it's going to look like this. Remember? All right, so let's multiply those y values, or divide these y values. 2 negatives divided by each other gives you a positive. Good. And then what's a number between here? Positive divided by a negative, and vice versa, that would be negative. And then positive, right? And so what do we know is going on? We have a positive slope to a 0 slope to a negative slope. This is a max. Now, this undefined location, is it defined in the function? Can I plug in 0 here? I can take the cube root of 0 and square it. And I can plug a 0 in here, right? That's part of the domain. So that means this must be a corner or a cusp. So then this is decreasing to an undefined, and I'm just going to make it a corner looking thing, right? It's probably curvy. And that's a minimum, right? And so this problem states we want to find critical points and local extreme values. Okay? So, what's going on at x equals negative 4?
Relative.
We got a relative maximum. So I can say y has a relative max at x equals negative 4/5. How do we know that? Since y prime goes from
Positive.
greater than 0 to,
Less than 0.
whoops, yep, when x equals negative 4/5. All right? Now, is this point stationary or not stationary?
Stationary.
This is stationary because the derivative is equal to 0. This is a stationary point. All right? Now, what's going, we have a relative minimum at,
X equals 0.
so y has a relative minimum at x equals 0. How did we know that using calculus? Since y prime
It's greater or less than 0.
that's less than 0 going to y prime is greater than 0 when x equals 0. And this one is a not stationary point. Okay, so that's number 35.
Okay.
37 is similar. So let me take a picture of that again so I can bring it down. Whoop. All right, so we're going to do the same thing. Sadly, we can't distribute on this one, can we? Because it's got a square root. Okay, so I'm going to write it in exponential form, though. This is x times 4 minus x squared to the 1/2. So what rule do I have to use? Product rule, so it'll be first. The second, which is power down function, lower the power 1, times the derivative of the inside, which is negative 2x, plus second, which is 4 minus x squared to the 1/2 times the derivative of the first, which is just 1, which is really nice. And now I'm going to do some canceling here. We're going to get rid of the 2's and then put things where they belong. So in the numerator here, I have an x and a negative x multiplied together, which gives us
Negative x squared.
negative x squared over, this is now the square root of 4 minus x squared in the denominator, plus the square root of 4 minus x squared. And that's the derivative, but I need to set it equal to 0, so I have to find a common denominator. So what's the common denominator?
Square root of 4 minus x squared.
Right, so we'll say y prime equals the square root of 4 minus x squared. Do I have to do anything to the first fraction?
No.
No. And then the second fraction I'm going to multiply by
Self.
yep, by itself. And then what happens? We get
4 minus x squared.
4 minus x squared. And there's no pesky negative to distribute there. So now I'm going to set it equal to 0. Negative, well, it's going to be 4 minus 2x squared all over the square root of 4 minus x squared. Now, this function itself has some domain problems. Don't you think, the original function here when I have the square root to contend with?
Yep.
Okay, I can't take the square root of negative numbers, right? So when x is bigger than 2 and less than negative 2,
We have issues.
I have issues. So the domain here is an implied negative 2 to 2, right?
Yep.
So I'm going to do my sign chart now. So I'm going to do a y prime line, and I know that I'm only going to go from -2 to 2. And now we're going to find our critical points by setting y prime equal to 0, which is when the numerator is equal to 0, which will be 4 minus, nice recovery, 2x squared equals 0. 2x squared equals 4. X squared equals 2. X equals plus or minus root 2, right? Alright, so I'm just going to put negative root 2 here, positive root 2 here. And the denominator is going to be 0 when? When x is equal to 2 and negative 2. So they're already on here, right? So these are the these are the stationary points. And then when y prime is undefined, right, that's going to be at x equals -2 and 2. These are the non-stationary, or not stationary. I have never seen the AP people ask about a stationary versus not. Yes?
Does it really help you to know that? Doesn't matter.
Only if it's particle motion, then you know it's not moving.
Okay.
You know, that's the only thing I can think to distinguish it from being 0 and undefined, and it's just another classification of critical points. Alright, so the denominator is always what sign here? Square root.
Positive.
It's always positive, right? So the only thing that's going to affect the sign chart is
The numerator.
the numerator, which is an upside down parabola. Yes?
Yep.
We can have fun with that. So I have zeros here, and then negative y values here, positive, and then negative. So what kind of points do we have here? We have a negative slope to a 0 slope to a positive slope, which is a min. And then we have a positive slope to a 0 slope to a negative slope, which is a max. Now what about the endpoints? What's happening as I leave -2? My function's doing what? Decreasing. So what does that make this endpoint?
A max.
This is a relative max. At 2. I meant to do like a curvy arrow, but it didn't work. At -2. So what about at 2? What's happening as I get to my 2? I'm decreasing until I get there, so that's also a relative min. Okay? Alright, so how are we going to say this?
Oh man.
Y has a, let's see, I'll start with the relative min. Has a relative min at x equals -root 2. How do we know? Since y prime
goes from greater than 0 to less than 0 at
x equals -root 2, right? And we already said that was stationary, so we don't have to worry about that. Y has a relative max at x equals +√2, since y prime is less than 0, then to y prime is greater than 0, when x equals √2. We already know that that's stationary. Stationary, right. Okay, so what about the endpoints? We said y has a relative max, is that right? At x equals -2, since y prime is less than 0. How are we going to say that? To the right of? After? I'm going to say after x equals -2. Does that make sense to everybody?
Yeah.
You're decreasing from -2. So if you're decreasing from that point, that has to be a relative max. And then y has a relative that's 37. I'm glad you guys asked me to do those two.
Me too. Took up like a whole page.
Well, I mean, what's really good about this is showing you the first derivative test in action, right? Because am I using the first derivative to justify my extrema? Yes, so then we're using the first derivative test. All right. Next ones are from 5.2, and that's number 36 was the one that was requested. And 36, find the function with the given derivative. Okay, so they're telling me that my derivative here is 1 over 4x to the 3/4, right? I'm going to rewrite this in with a negative exponent. So that's going to be 1/4 x to the negative 3/4. And they're asking me, what did I take the derivative of to get there?
Oh.
So what did I take the derivative of? Well, I've had to bring the power down.
So the power is.
So I'm suspecting this is x to the 1/4, right? Because I had to bring the power down. Function, lower the power 1. Well, does that work?
No. Yes.
Yes, it does. Okay, except that it could have been x to the 1/4 plus 9.
So
Plus
C.
pi. Yeah, so we had to put a plus c. Right? But then they said that it has to go through the point. This function has to go through the point 1, -2. So are they giving me enough information to figure out
C.
c? The answer is yes.
-2.
So I'm going to put -2 equals, I'm going to put solving for c. -2 equals, well, 1 to the 1/4 is just 1 plus c, so c equals -3. So I could say that my f of x, from whence this came, this derivative, is x to the 1/4
-3.
minus 3. It's just asking you to go backwards.
That was simple.
Okay? Number 43 was the next one that was asked. Oh, wait. I don't have that one, so let's insert a blank. Am I at 5.2? Insert blank page. The good news is that I can recover. We need 5.2. Number, what is it, 43?
Can you also do number 27?
In the same section? I can find it.
There.
There it is. Okay. Yeah, I'm glad you asked about that one. All right, hurry up. New. I'm going to get the whole thing here because I've got to get the instructions. All right, let me insert another blank page and get, what is it, 43 and 45? I don't know what I was just stopped, I guess. 43.
Did you want me to pause this?
Yeah, go ahead.